has to start momentarily. There we go. Anyways, so what do I read? The first two or like just one? I assume it's the first two, am I right? Um, you're muted, Mrs. Rittenhouse.
So sorry. Yep, if you'll do the first one and Ireland will do the second two.
Okay, thank you, thank you. All right, so describe photosynthesis. Thank you.
Describe cellular respiration. What burning of fossil fuels creates what? Is this problematic?
Great job. Thank you so much. Oop. Where am I? Here am I. My internet is slow today for some reason. Just everything when I pull it up is spinning. So please let me know if having my video on ever ends up slowing anything down. All right. So yesterday, what two cycles did you go over? We're talking about ecosystems. We're talking about how things living and unliving interact, right? So we've been talking about how species interact in environment. We've been talking about how yesterday how the abiotic components, like water and nitrogen, which are important for life, are cycled through our ecosystems. Which one were you most familiar with? The water or the nitrogen? The water.
Yeah, because remember at the beginning, Miss Schmidt the third played some Go Noodle at the beginning. It was about the
Yes.
water cycle.
Did you guys like that video? What was the beginning of it? It made me laugh. It's like, oh, we're getting thirsty in here or something like that. She was talking to me about her resources for it. And she said, well, I learned a song about the water cycle in third grade. Do you think I should sing it? And then she sent me that video. So I love it. She was excited about it, and I thought she did a great job jumping in and throwing in some new resources. So the water and the nitrogen cycle. Yes, you've seen it before. So let's talk today a little bit about how two other important things in the ecosystem are important. Let me see what this comment is because I missed it. I want it lets me scroll. Awesome. That's fine. I actually thought that was a good example of a cycle. So I was about ready to be like, all right, that makes total sense, Eva. It's a cycle, right? Actually, I may use that. I may use that today, okay? Because that's something we're familiar with. So, carbon and oxygen. We talked about those both. Tell me about carbon. What do we know about this element, carbon? No stress at all. Don't even apologize. Actually gave me a good idea. Tell me what you know about it's an element. Carbon is an element. Periodic table. You wouldn't recognize it by the letter C. It's a part of life. What kind of a molecule do we call it? Starts with an O. It's an organic molecule, right? And all living things have carbon in it. All right, so let's look at this. Carbon, right? It is the abiotic component of all biotic things, right? So it cycles through Earth through living things. Anything that ever has been alive in it has carbon in it. Can someone tell me about carbon dating? We talked about carbon dating and how we can tell how old something is or new something is based on. Oh, we got something. Got a little something going on the board. That's all right. Good. Good. So some radioactive dating where we go back and we look at a fossil, and based on that, how much carbon is in that fossil, we can tell how long, based on the half-life, good, that fossil is. All right, so carbon is cycled through our planet, through Earth, through living things, right? Let's talk about the carbon in a caterpillar. All right. The carbon is in a caterpillar. What happens to the caterpillar next? Oh, that's cool, Pip.
Yeah, I just wanted to show this real quick. I actually made this last year and I thought of showing this. It talks about radioactive dating and carbon dating. I might show the full thing and put it on the Padlet soon.
Yeah,
But
do
I just
that.
wanted
That
to
looks
show that.
great.
I just made it by hand and showed it to my physical science teachers one day and they really loved it. I'll put the whole thing on the Padlet soon. So yeah.
Please do. Thank you. That looks great. Your hair is looking extra good today too, Pip. Yeah, girl. Awesome. So yes, carbon. Let's talk about it. Is it in a little baby caterpillar? What happens to our caterpillar next? What happens to a little caterpillar eventually? It grows. And then the caterpillar goes to sleep for a very long nap in a cocoon, right? The caterpillar turns into a butterfly. So now here's Mrs. Rittenhouse's butterfly. The carbon is in the butterfly. And then one day it gets too cold. Let's not say a bird eats the butterfly. All right. Let's say it gets too cold and the butterfly dies. Oh no. This beautiful little delicate butterfly dies in the bushes as it was pollinating a flower. Okay. I know. We all know that butterfly so well. What happens next to the carbon that is in our precious, beautiful little butterfly? Ooh, love it. So, time and pressure. I love this. Time and pressure. It does. Time and pressure. If things are hard bodied and have bones, a lot of times they can form fossils, right? If they're in like a wet environment, like a creek bed or near the ocean or a river, but like a delicate little butterfly, when it is exposed to the elements over time, it is going to decay, right? And so, where is that carbon from the butterfly going to end up going? It died in my bushes. Okay, some things may be released back to the air as chemical reactions occurred. Agreed. Yes. And the rest of it is going to go into the soil, into my flower bed. Right? So now the carbon is in my flower bed. It is in my flower bed. Does it stay there? What else is in my flower bed? It kind of acts like fertilizer. I like this. What else is it growing? Where was the butterfly when it died? It was on a flowering plant. What do you think happens after that carbon is down in the ground? Yes. So some things may be released to the air and other things may be absorbed by plants from their roots, right? Because it died in my flower bed. There are plants in my flower bed. So it may be giving life to the very plant it died on. How beautiful is that? But yes, so yes, carbon is everywhere, right? Because Anywhere there's a living anything, I'm looking out my window. I see grass on the ground. I see trees. I see the top of some large bushes. What do you see? I see living things all around me. So if there are living things all around us, yes, there are going to be traces of carbon almost everywhere. Cool? Put something that you see right now that is living. If you have an open window or a house plant or people or animals in your house. Everybody. Jesse sees a bird. What else? What else do you see that's living? A puppy. Good. Crows, a cat, a plant. Like I said, grass. Ooh, a squirrel. I saw the cutest little squirrel the other day. Crows, your dog. Good. Your mom is a living thing. Chipmunky. Good. These are all living things. Okay. And so there's not going to be a place on Earth that you're not going to be probably able to find carbon. Now, there are areas on Earth where there are less amounts of life, but we're going to find it. All right. Let's look at the process of photosynthesis very quickly. All right. We take carbon dioxide, we add water and sunlight, and we get this over here. All right. What is this important for? Why is glucose important? Energy, right? ATP. Everybody type ATP. Anytime we think about energy, glucose, plants, I want you to connect that with ATP. That's what our body needs to fuel.
ATP chain.
Good. And so we start making sugars from any plant life that exists outside, right? So not only is there carbon in all the living things that you see, but anything that is green out your window. If you have a window, look out your window, like the grass that I'm seeing. Right now, that tree is not very photosynthetic because there are no leaves on it. All right. But there is photosynthesis constantly occurring. So we're constantly producing carbon traces. Okay. Which one of these numbers might represent photosynthesis? Where do we see photosynthesis? Coming from the smokestack, coming out of the ground. Yes, 3. From the sun to the plant. We're creating a carbon-based molecule called glucose through photosynthesis. Okay, good. We talked about this for an entire unit, cellular respiration, how you're going to break down glucose, right? So you break down your glucose through a process in our cells called cellular respiration. We take it, we add water, just like you're baking, right? We get our glucose from our food that we eat. We get oxygen from the air. And what do we put out? We put out carbon dioxide, we put out water, and we get energy in the process. So let's look at this again. What numbers in this diagram? All right, we're looking at carbon again. All right. Is carbon dioxide entering the atmosphere by cellular respiration? Yeah. Good. You guys are awesome. I would say 2 and 4, right? Because our plants and our animals, they are using that glucose. Yes. I'm so proud of you guys. High five. They're using that glucose and breaking it down. So they're chopping up that molecule And when they do that, some of that carbon dioxide, right? That carbon, another carbon molecule, is being admitted back into the air. Good job. Again, and this is just that reminder that photosynthesis, the bringing in of light and the making of glucose, and cellular respiration, all right, how we take glucose and break it down are just opposites. See that? The oxygen and the sugar, they put off, and these are what we need to start photosynthesis. But you probably don't even need that slide because you guys are awesome. So here's the overarching picture, all right? Here's the overarching picture. If you're snipping something, this is a good one to snip. Right? We talked about over here about photosynthesis, how we bring in our carbon molecules by making glucose, right? And how some of that glucose is eaten like by our animals and used by our plants. Right? Eventually, look, blah, 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 the cow dies, dead organisms and waste products are going to bring it back up. Or even, I think it was Dustin talked about over time, right? Some of that is going to seep deep down into the soil, and over time and over pressure is going to be changed, right? Then you're going to have it being re-respired, plant respiration, animal respiration. We're taking the energy that we made, we're breaking it back down, and we're putting that carbon back into the air. Other sources of carbon dioxide emissions are going to be from the energy put out by vehicles and by factories. All right. Because they're doing a similar process. They aren't going through cellular respiration, but there are other chemical processes happening here and here that are also putting out carbon. How does that make sense? Green check, red X. You guys are doing so well. You're following with me more than I thought. Yes. Good. Yep, you're right. That mineral carbon turns into things that we use to fuel the cars in the factories, like oil, natural gas, coal, those fossil fuels. Absolutely. So impressed. Good. If you're not quite there yet, spend some more time today going through this. So clip this right now, snip it, then come back and listen to this recording, okay? Come back and listen to this recording. Somebody tell me where I post these recordings every day, or at least every week if it's not immediately after class. YouTube, we have our YouTube channel, and I have been even better at putting them inside the classroom. Where am I putting them in the classroom? Anyone know? In the announcements. Yep. If you go to the announcements, I've been posting underneath our calendar. I've been actually posting the YouTube recordings from the week in there. Okay. I don't feel like a bunch of people visit the announcement page for the amount of time that I put into the announcements, but it is there. So feel free to utilize that. Okay. Before we run out of time, because it is 8:51, let's look through the oxygen cycle. The oxygen cycle. Okay. Tell me what we know about oxygen. Oh, thank you, Kai. That does make me feel better that you like them and that you use the announcements. We breathe it. What else do we know about oxygen? It's a plant's waste product. Okay. We breathe air. Good. It's in our atmosphere. Byproduct of photosynthesis. It's in water and soil. We all need it to survive. Yes, these are all so good. Okay, so we're very familiar with oxygen. Like if it was a picture of a face, we'd be like, oh, that face is so familiar to me, right? So there is ways that oxygen is cycled through our ecosystems too, right? I would say this is probably one of our most familiar, right? In plants and animals. Like we breathe it in. Everybody take a deep breath. We're going to do some in-class yoga. In your nose. Out your mouth. Yep, quick check is next. In your nose. Out. Are you doing it with me? Is anybody doing this with me? Yes. All right, this is actually a really good way to calm yourself down. So in a moment of anxiety or stress, or getting ready for bed or waking up, believe it or not, when you do it, it gives your body so much more oxygen. It floods your cells with oxygen, which has a lot of good biological things. Good. Square breathing. I love it. All right. When you are doing that, you are flooding your body with oxygen. And then when you breathe it out, what are you breathing out? CO2, right? What is in carbon dioxide? What is in carbon dioxide? 1 carbon and 2 oxygen. Say what? So tell me about that. Seriously, we get rid of oxygen, but we breathe out oxygen? What? So when we breathe in oxygen, we breathe in what we call O2. Right? We don't just breathe in singular oxygen molecules, we breathe in the element O2. All right. And when we breathe out a compound CO2, right? Good. So we have it goes in and we use it and we make compounds before we send it back out, which is what plants need, right? So in plants and animals, oxygen is removed from the atmosphere. All right, we can breathe it in. We also use it during what we just talked about, cellular respiration. As we break down glucose, we need oxygen to do that. All right. Look down here. 90% of Earth's oxygen is stored in the minerals of the Earth's crust and mantle. Where is the Earth's crust and mantle? What is the Earth's crust and mantle? I think about crust and I think about pie. I don't think about what. Yeah, the Earth's the ground that you're standing on, right? The layers of the earth in which we're standing on. So a lot of the oxygen is actually leaving from the Earth's crust and mantle through a process we call weathering, right? As rain hits the soil and as plants and things decay, there are reactions that occur in the soil and oxygen is put back into the atmosphere, right? So from the Earth's mantle, from when organisms decay, right? CO2 is released. The process down here of rocks and minerals themselves breaking down sends oxygen back into the air. All right. Through photolysins, oxygen gas is released into the atmosphere when light energy breaks apart water and nitrate molecules. All right, nitrate is a nitrogen formed compound that comes from things like fertilizers. Okay. When the shells or marine life are down here, they put off oxygen. Right? So you have all kinds of organisms and Earth itself putting oxygen back into our air and our ecosystems, right? We breathe it in, plants take it, or living animals take it in, plants put it out. Dying things put it out. Decaying processes putting it out. And the process of Earth weathering puts out oxygen. All right. So you need to just kind of have a general knowledge of the input and output of oxygen. Let's do this because I know you guys value this. So which arrow represents carbon dioxide entering the atmosphere by cellular respiration? Let's do this. Carbon dioxide entering the atmosphere by cellular respiration. I said 2, and that's not untrue, but 4 is showing us that it's plants and animals. We also don't want to forget this guy over here, because this is carbon dioxide re-entering the atmosphere as well. But this is entering it by cellular respiration, right? So 2 and 4 would represent by cellular respiration. This one is still outputting, but is this cellular respiration? No. Sorry if I just confused you. I just wanted you to realize this is still an output. Good. So 2 and 4, B is the correct answer. I usually have you guys read these, but because we're running close on time, I'm going to do it. Actually, we have 10 minutes. I'm fine. Why am I stressing out? Somebody want to read number 2? All right, we'll have Pip read number 2 and Ireland read number 3.
All right. Neuroanimated me. Anyways, which arrow represents carbon dioxide entering the atmosphere because of the use of fossil fuels? A, 1, B, 2, or C, 4. Please don't choose D unless you feel like you're trying.
Right, fossil fuels. You're right, Ava. All right. So this is going to represent us using the fossil fuels like coal and oil, our natural resources that were in the ground over time and pressure. And then we break them apart and use them. And when that happens, oh, I didn't do polling. I'm so sorry. Right? That would be 1. Good. 4, this is perfect. This is the answer 2. Again, this is put out by cellular respiration by plants and animals. This is going to be our non-cellular respiration source. Great job, guys. So, Ireland, let's read number 3.
Which arrows represent photosynthesis and cellular respiration? A, 2 and 5, B, 3 and 4, or C, 1 and 4?
All right, so which arrows represent photosynthesis and cellular respiration? Photosynthesis and cellular respiration. This is a little tricky. So photosynthesis takes in carbon dioxide, right?
Yeah, we need polling.
Oh, I'm so slow today. Sorry. What do you think? I don't necessarily love this question. I guess I do. I wish there was an arrow just of the tree in and the tree out. But I guess these two are good. This is right here, photosynthesis, right? Because it's coming from the sun and going into the tree. And then it's showing how it's going out of the tree via just from cellular respiration in the tree or from the deer eating the tree and it going back in via the deer. All right, so if you chose B, you're correct. in my mind, it feels like it should just be the tree, in the tree, out of the tree, but I understand, which would have been 2 and 3. But it does kind of look like a moose, doesn't it? It does kind of look like a moose. Maybe it is a moose. I like I would like to be looking at a moose.
Yeah, it is a moose. I can confirm.
Pip confirms. It's officially a moose. All right. So, before we do the next step, how do we feel? Do you feel like you can describe photosynthesis? Yes or no? Right? Photosynthesis is how our plants make energy by bringing in carbon dioxide to their cells and make glucose. Good. Cellular respiration. Yes or no? I see moving yeses. Can someone describe cellular respiration like I just described photosynthesis? So photosynthesis is taking in carbon to make glucose. What does cellular respiration do? Don't be nervous. You know it. Good. Good. So what is it doing with the sugar? Yes. Burning glucose. Breaking glucose. Right? That puts carbon dioxide back, or that puts oxygen back into the air and breaks that carbon dioxide or sugar. Yes, perfect. You know it. I know it. All right, everybody, put your arrows in this corner. Burning fossil fuels. Why can this be problematic? Could you tell me that? We didn't really cover that today, but I think most of us know. Right? CO2 adds up and it can hurt our ozone layer. Is this my slide? All right, this is talking about the levels of carbon dioxide over time growing, right? Because we are putting out more CO2 into the air, which can hurt the Earth's atmosphere and climate, and that's where we talk about global warming. Does that make sense to everybody? That's all we need to know. The extra CO2 influx over growing industry and growing output of CO2. Deforestation can is a contributor, right? Because if the less trees you have, you don't have as many many producers absorbing and putting out oxygen, helping contribute to that process. Good. All right. What I want you to do, but your next class starts at 9:15. You have time. You have time to take your quiz for today. Maybe you want to complete your assignment right now. Maybe you want to go make some flashcards on some words that you're like, I don't know that. Maybe you want to play a review game. Maybe you want to go do one of those flowcharts that we talked about and I gave you those instructions for. If you don't have that link for those pictorial notes, it's in the announcements. Okay? I am going to let you go, but I want you to show me what you're going to do right now with your arrows. As you leave, we have a quiz due today. So my encouragement today is log in right now. A lot of you are hitting complete assignments. I'm going to put up the quiz check because, hello, that's where you're going. Go take that quiz while these are fresh on your mind. Go ace it. Take it till you get 100%. Have a fantastic day, guys. You make my day so much better. Seriously. My day is better because each one of you are here. You're going to have a great day, a great week. And if you need that reminder or any help, pop in a help session and I will remind you of that. See you, sweet friends of mine. I will see you soon. Have a great day.